Okay, what's up with TikTok? Hey y'all, I'm jumping on live. I'm about to do a coding challenge. I just need a second to figure out why TikTok isn't working. Okay, I have no idea why TikTok isn't working. All right, I have to go do TikTok on my phone. Sorry, y'all. Give me 1 second. This is annoying. TikTok isn't working. All right, this is stupid, man. Yeah. All right, so we're live. My bad, y'all, on TikTok. My stream is acting crazy, so I gotta stream from my phone tonight. Try to get it right. But this just had to be good enough. And y'all might not be able to hear me too good on TikTok, but I'm gonna guess that's just gonna have to be how it goes this time. So, cause TikTok ain't working worth a crap. Yeah, this stream thing isn't working. I don't know what's going on with TikTok. Oh, and then I just messed that up. All right. Gotta do this bootleg style with the camera. Oh man. Yeah, man, TikTok failed me today, man. The stream key isn't working, so I gotta stream from my phone. So I just got it propped up in front of the computer. So that's just how we're gonna rock with it tonight. I'm live on all the other platforms though. If you want to switch to another, if you're on TikTok, you want to switch to another platform, you can do so. But yeah, So I want to see you write some assembly, G. I mean, I haven't wrote assembly since college, man. So it's been a while for that. But maybe I'll get on here and do that one night, like write some assembly just to like practice it and, see what it looks like after all these years. But tonight I'm gonna do this coding challenge. I hate to have to do this on TikTok, at least on this stream, on the video. But yeah, I just gotta plug my camera up and do it like that. So if you want to switch to YouTube, Twitch, X, or Instagram, if you switch to one of those channels, the stream will probably be a little bit more clear than it is on TikTok. But probably the most people are gonna be on TikTok. So the most comments, the most people are always on TikTok. Just how TikTok works. So usually the most people end up coming in on there. But you can follow me and watch from any different channel, KG.codes. But anyway, what I'm gonna do tonight is this coding challenge. I've been doing these for the last couple weeks, or probably last 2 or 3 months, every night. Not every night, my bad. Every Friday night usually. If I can't get Friday night, I'll do Saturday or like Monday or whatever. But usually every weekend I'll do one coding challenge. I've been doing mediums for like the past 3 weeks, medium level problems. So they've been taking a long time. I'm gonna try to go through this one a little quicker and maybe try to get out of here in like an hour or two. Maybe answer a few questions along the way, explain my thought process, explain the problem. I will be doing this probably in JavaScript. Lone Dean, what's up, man? What's going on? Chance Stearns, find something you like in the field, genuinely enjoy, go after it. Depth first search plus breadth first search, easy problem. Do it in Python. I'm gonna do it in JavaScript. I'm taking CS50 on the Harvard site. Maybe want to go to school for computer science. Definitely, I recommend that. I'm not a proponent of like bashing college. I still think it's a good way to code. It still looks really good on your resume. So, I don't think there's anything wrong with that. Good luck with school. The tips I would give you is, just stay on top of your work and really try to learn how to code. Don't just try to skim through the process. In college, it's kind of easy to try to skim through the best you can, but try not to do that. Try to do projects on the side. I really don't recommend doing too many side projects in college. Just really focus on your work. But if you're interested, you can do some stuff on the side. But really not necessary. As long as you're keeping up with the coursework, you should be pretty good. Just get the degree. That's really what you need to focus on. Anyway, I'm going to go ahead and get started on this problem, man. This problem is nice. Do you work at a tech company? Yeah, I'm a principal software engineer at like a mid-sized tech company. Passed a lot of these interviews before with these style questions on it. And the reason why I still do these, I know we're in the times of AI and I know some companies aren't asking these anymore, but there's still a lot of companies that are asking these, especially like the FANG companies, the Facebook, Amazon, Apple, Netflix, and Google, Microsoft. Some of these big companies are still asking these as of today, at least from some of my coworkers and ex-coworkers that have been getting jobs lately. They still have to do these. Like I just talked to one of my coworkers' friends like yesterday, and they still ask these in the interview. So that's why I still jump on here and do these to help people learn, to help myself learn, help myself practice, stay up to date, or not even stay up to date, just practice. And then, a lot of people jump on here in the comments and they teach me stuff too. So, it's a learning experience altogether. So that's why I jump on here and do these still. I don't agree with these problems for interviewing. I don't think it's the best way to interview. But if you've been doing software engineering, there is usually a level of jobs you won't have access to if you don't learn how to do these coding challenges. At least for right now. Hopefully that changes in the future, but for right now, if you want to get to like the FANG level compensation, there's a lot of jobs locked behind these style problems. And when I say FANG level compensation, I mean like a total compensation where you getting a large sign-in bonus, like tens of thousands of dollars in sign-in bonus. You're getting a large base salary, and then you're getting a large stock compensation as part of the total compensation package. A lot of the smaller companies can't offer that because they're not public companies. They don't have stock, or if they do, they may not be big enough to offer that the style of these like big, huge tech companies, like the tech companies that are like, top of the the hill, like the Facebooks, the Googles, the Apples, the Microsoft, stuff like that. But it's not impossible. Like, a lot of the companies have decided not to ask these questions. Some interviewers have decided not to. So it's possible to get around it. But that's the reason I still ask these. Because a lot of people are going to come in the comments and say, like, why are you still asking these? Why are you still doing these? And that's why. Hey, Zero Clap, what's up, man? Good luck, G. Appreciate it. I'm going to start on this in a minute. Any thoughts on hackathons? I think hackathons are great. A great way to kind of like expand your mind and work on your problem solving skills and work under pressure. Like, I think hackathons are great. I don't do too many of them, but I think they're great. They're a great way to kind of like take you out of that mindset of like just doing tutorials and like thinking outside of the box. Like, I think they're great for that. Sounds like what I'm doing is a Chance Stearns. Sounds like what I'm doing is a good start. Oh, you're talking to somebody else. Yeah, I'm glad everybody's talking to each other, man. Like, it's so many. Every time I get on here and do these, I just surprised that, like, especially on TikTok, like the community of developers and technical people that jump on here, and like, you would think that it's just dancing and stupid stuff on TikTok, but there's a lot of knowledge and a lot of people on TikTok that jump on here and share a lot of stuff and help me, and hopefully I'm helping other people by doing these and answering questions on here. So. But yeah, I'm a software engineer, been in the industry a really long time, had to do a lot of interviews with these. I have to conduct interview with these type of problems. And tonight, what I'm going to do is try to quickly go through one of the most famous medium level problems on LeetCode.com called number of islands. It's a grid problem or a matrix problem, or I don't know, would this be called a matrix or just a grid? I don't know. Somebody sound off in the comments. I don't know, but it's a lot of people in the comments already have done this problem before. It's a famous one because I see the comments, they're screaming about the solution. So I understand, man. I understand that y'all I understand that y'all, like, a lot of y'all might already know this, but there's gonna be some people that come on here that don't do these, and this one is a hard one. If you haven't practiced these problems, you just randomly saw this on the interview, you probably wouldn't solve it. I don't know many people that could just solve this from just plain intuition. Like, you'd have to practice these problems to kind of solve it. So anyway, shout out to my people on YouTube, TikTok especially, Leedy DS on YouTube. Appreciate you joining over there. But yeah, we about to go ahead and jump into this thing, man, so I can get through it. Get off of here. Everybody can enjoy the rest of their Saturday. This is how I spend some of my Saturdays, man. Usually I do these on Fridays so I could do something else on Saturday. But I was tired last night, so I didn't do it. But we're gonna rock the Saturday night with a leak code problem, and then I'm gonna go watch a movie or something. So yeah, let's go ahead and get started. All right, man. Number of islands. It's leak code problem medium leak code problem number 200, and it goes as such: given an m times n or m by n 2D binary grid, which represents a map of ones land and zeros water, return the number of islands. Let me read that again because I said it kind of crazy. Given an m by n 2D binary grid, which represents a map of ones, land, and zeros, water, return the number of islands. It's already starting off bad, man. I can't even talk. An island is surrounded by water and is formed by connecting adjacent lands horizontally and vertically. You may assume all four edges of the grid are surrounded by water. All right, so what they want you to do is basically you're looking at a 2D grid, so it's just like, it's not a, let me see. Yeah, it's not a perfect square. So maybe a matrix is a perfect square. So yeah, the M is the like number of rows and N is the number of columns. And you just got a map with ones and zeros in it, and the ones represent a space of land, zeros represent water, and they want you to return the number of islands. An island is surrounded by water, obviously, and connected by adjacent lands horizontally and vertically. You may assume all four edges of the ground grid are surrounded by water. So everything around here is water around outside. But basically, they want you to find these contiguous pieces of land and count how many contiguous pieces of land are. So in this one, you got this land, which is connected here, and then it's connected to these two here. And that gives you one piece of contiguous land. All the rest of this outside of here is 0. So you should output 1 as the number of islands. You just got 1 island. But this is the one that's more interesting. You got this piece and this piece connected together. So that gives you 1 island. You got this piece that's by itself. It's surrounded by all zeros. So this is an island on its own. And then you got this piece that's surrounded by all zeros. So it's an island on its own. So that actually gives you 3 islands. And you need to programmatically write a algorithm that's able to take in this grid, which is an array of arrays. That's how you represent the grid in most programming languages. Is an array of each row is an array, and then each column is its own array to make up the columns in each row. So, and then they want your algorithm to spit out the number of islands. And so they got some constraints here. If you're in an interview, after you read the problem, the interviewer may give you the constraints that may be part of the problem definition, but sometimes it aren't. You may have to, or isn't, you may have to ask for those constraints yourself. So if you, that's something you get used to as you do these problems, is like knowing when to ask for constraints and how that affects your problem, how that affects your algorithm and what you have to write. But here, basically it is saying M is the grid length. Just like I said, I kind of assumed that anyway. So the grid length is the number of rows. That's how many, 1, 2, 3, 4. That's how many rows I have. So grid length. And then grid I length, that means at each one of these spaces, which is the columns, that's equal to n. So the columns is equal to n. So I is just represents whatever row you're on, and the length of that row. And the length of the row is always the same. So that means whatever this n is equal to the number of columns. And they're basically saying n and m is going to be greater. It's always going to be at least 1. So you're always going to have at least 1 by 1 grid. And then it's going to be less than or equal to 300. So it'll only go to 300. These constraints are actually important because that means I don't need to handle a case when I have an empty grid. So I don't even have to worry about that. And then it also means that this just means that at worst case, I'm gonna have a 300 by 300 grid, which shouldn't be a problem for most programming, like modern programming languages, to handle as far as the data structures I'm going to be storing this in, the variables I'm going to be using. Like, it shouldn't be any overflows happening. It shouldn't be any like runtime errors from the amount of data. Even if I run like, expensive algorithm, if my algorithm isn't that optimal, I'm only doing 300 by 300, which seems like a lot. But in the sense of like scale and programming, it's really not that much. So that constraint is very important. And then, the grid at I or J, that's I is the number, the row that you're on, J is the column you're on. It's always going to be 0 or 1. So I don't have to handle some kind of case when this is not 0 or 1. Everything's either land or it's water. And so this is an important constraint too, because my program, this being a constraint, you want to know what the constraints are, because then you don't have to program in all these edge cases. So it's good to ask the interviewer what the constraints are. Like, even if the problem says all this stuff, like, you might want to ask. I mean, the problem literally says the constraints, that it has to be 0 or 1s, but like sometimes you might want to ask and just make sure you have that noted down, because let's say that there could be boats on the water that are like 2s or whatever, and so that would mess your algorithm up if you didn't account for that. But in this case, we don't have to worry about that because it's under constraints. So those are things you want to talk about in an interview. In the interview, you want to make sure you understand the problem first. And if you've seen me do these before, like how I like to do it is kind of think through how I would do it in my head first, and then try to translate that to data structures and algorithms that I'm familiar with as a solution. And so when I'm looking at this, I mean, of course, some will ask, like, you can just eyeball it and tell how many islands. As a human, you can just say, okay, I see an island here, I see an island here, I see an island here. 1, 2, 3, I got 3 islands. Here I got 1 island. Of course, but you got to think about it in the sense of a computer. Because last time I got on here, everybody's like, well, you can just look at it and tell. And it's like, you got to think about it in the sense of a computer that doesn't have eyes. Like AI, you can send AI a picture, but it doesn't have eyes. Like, it's still processing whatever you send. Like, if I sent this grid into ChatGPT, it's still reading it. It's reading it each character by character and knowing what each character is. Even when it's an image, it's still processing every pixel of the image and making some prediction based on that, some token prediction based on that. So you got to think in the sense of a computer and not somebody with eyes and a brain. And so when I think about it like that, then I'm thinking about, I need to find the contiguous areas of ones and ignore the zeros. Basically, I need to find out where I have a contiguous area of ones that's surrounded by zeros, just like when I did it in my head, like just my eyes or whatever. My eyes, I'm just looking for stuff that's surrounded by zeros completely on all sides, and then I count that as a 1. But if I'm a program, I know that I'm gonna have to go through these pretty much one by one to check what every value is. Like worst case, I need to check every single value in this thing. So I already know every value's got to get checked. I got to make sure I look at every single thing so I know how many islands there are. Because I could find this island, and then there could be an island all the way on this last one. This could be a 1, and that would make this 2 islands if this was a 1. And I'll probably add that as a test case at the end. So I need to check every single one of these. So I'm thinking about, I would just loop through these, and then somebody said, are you going to actually code or keep talking smack? Man, that's if you get in an interview, man, you have to talk through your solution. Now, you may not talk as long as me because I'm talking to y'all and I'm trying to help people kind of learn about the interview process and or at least think about it, and remind myself about the interview process. But if you're in an interview, if you just jump straight to the code, that is not a good practice to do. Like, you don't want to just jump right to the code, because you don't give the interviewer a chance to give you any hint. You don't get the interviewer a chance to verify your solution or to give you some sort of like, okay, I think it's good for you to proceed with this approach that you've explained to me. If you don't do that and you just jump to the code, most of the time, they're not going to help you. Like, they're just going to be like, okay, well, he's just jumping the code. Like, so that's not good practice. You can ask anybody that. Like, if you're doing these problems, it's not good practice just to jump straight to the code. But for y'all's sake, because somebody said yap code and all that stuff, for y'all's sake, I'll go a little faster. But everybody's not a pro. That's probably watching. Like, some people, need a little bit, are new to this. Like, they're not just they haven't done this 1,000 times like some of y'all may have. So anyway, yeah, how I'm thinking about this is I'm going to loop through each one of these things. So I'm going to check every value. And when I find a 1, I actually want to look around it to see if I have 1s or 0s around it. If I have any 1s around it, I actually want to mark this one I want to somehow mark it as some sort of way to know that I've already checked it. So I could mark it as visited. So I would mark this one, cross it out, and then go to this one. I know it's a 1. And so what I actually want to do, I want to check everything that's around. I want to check to the left. I want to check to the corner here. I want to check, or not. I actually don't want to check down here. I just want to check to the left and to the bottom. And so I check here. I got a 1. And so here I want to check all around it to see if I have any 1s. I want to check over here. I want to check down. And I want to check over here. But over here, I've already marked it. I've seen it. So I'm fine there. But here, I want to check to see if I got a 1. If I got a 1 here, then I want to check around it. Here I have a 0. I know I can stop here. I don't need to keep checking because that's water. If I get here, I know I got a 1. And then here, I want to check around it. 0. I got a 1 here. So then I want to move here. And then here I see I have all 0s because I probably marked this one as seen already. That process I did, I would actually do it when I went here. I would do it when I went here. I would just keep recursively checking as I get to as I find a 1 around wherever I'm at. I would just keep branching out until I got to the point where all I saw was 0s all around and I couldn't keep going. And once I get to that point when I can't keep going, then I'll mark that as one island. So basically it's like I'll start at a 1, and then I'll just keep searching all around with code until I find all the ones that are connected to that 1 that I start with. So every one that's connected in a chain, any direction to the 1 that I started with. And then I'll mark that as 1. And then I'll keep looping through here till I find another 1. This is probably a better example. Like I would start here, I would find this 1 here, mark it. I would find this 1 here, mark it. Then I would find this 1 here and I mark it. And then once I see zeros all around here, then I know I can't keep going. I would mark this and this one as one island. Then I would keep looping through until I find this 1. I would look around it, see nothing but zeros in a circle around it, and I would just mark it as 1. And then I would get to this 1, and I would look and see only this 1 on this side. And then I would see that, okay, I got zeros all around it except for this one I already seen. And I would mark this as another island, and then I would get 3 islands. So that's how I would do it. Basically, that's my solution that I'm thinking of in my head. So now how do I convert that to data structures and algorithms? What you want to do is explain that to the interviewer. And let me move this freaking thing out the screen. You want to explain that to the interviewer how you're going to do that. And so you can just jump to code, but if you don't explain your solution to the interviewer might give you a hint if you're going in the wrong direction. That might save your whole interview. So you don't want to just jump into it. Now, do you want to talk as long as I'm talking? Probably not, because I'm like in a meta stage of talking about the interview process itself. I would be talking about the interview process in the interview, but I'm trying to, help and explain and talk through it for myself and talk through it for people that may be watching that are new to this style of interview. Because this style of interview does have a structure. You can't just jump in there and just start coding. If you jump on, even if you get the answer right, it's possible you might fail the interview. If you just memorize this solution and just jump to the code and just write it without saying a word to the interviewer, you might fail it, because they're not just trying to see that you memorize the answer from lead code. They're trying to see that you understand what you're doing. Like anybody can memorize some text and just write it and regurgitate it. And so that's kind of what we're getting at here. But anyway, how I would take that solution to code is I would think about how I would do the solution that I just talked about. It's not really something that's going to come intuitive. Like it's not going to just be part of your intuition. It's something that you would have been something you would have to have practice and learned your foundation when you start doing these problems, as far as data structures, as far as algorithms. And two of the algorithms that you would end up learning when you start your foundation. So that's why when I jump on here before, I haven't said it tonight, but when I jump on here before, you want to learn your foundational things, your data structures in the language that you're using, and the algorithms. You want to learn those first before you jump heavy into these problems. It's okay to do a few easies first, but then you want to start learning how to write data structures and how to write the algorithms around them. When you start doing that, you'll learn two of them. You'll learn is depth first search and breadth first search, which are 2 algorithms that help you search a data set, particularly a grid or trees. Those 2 data structures, like this here is a multi or 2-dimensional array. Array of arrays, otherwise known as a grid. And two of the things you can do on it is called a depth first search and a breadth first search. What I actually want to do what I said is a breadth first search. A lot of y'all commented, especially on TikTok, y'all already commented it, which is great. I know y'all done the problem before, so that's great. But what I want to do is a breadth first search actually. And so how that works is I'm just going to start looping through these until I find a 1. In this case, I'll find a 1 instantly right here. And then I want to conduct a breadth first search on this. What a breadth first search would do is anything connected to this, I actually want to go continue my search in that direction of the things connected to this. So when I get here, I want to start a breadth first search on it. And what a breadth first search is it looks at all the siblings next to the thing that you're currently searching. And the siblings in this case is the one to all the adjacent cells. So the one to the left here, or my bad, right here, and the one to the bottom. And then once I go here, I want to check its adjacent siblings. That's this one, that's this one, that's this one. And then when I go here, I want to check its adjacent siblings. And when I do this, every time I check these adjacent siblings, all I want to do, or neighboring siblings, whatever you want to call it, all I want to do is check if I'm getting another 1 or if I'm seeing all zeros. So if I'm seeing another 1, I want to go and do a depth first search on that next one and just keep searching till I find all the 1s, and then stop when I get surrounded by zeros, and then I want to add a 1 to my count. I want to keep some sort of counter somewhere that I can count the number of islands I've seen. But what a breadth first search is, what that'll do is when I start here, it'll actually help me navigate through all the connected adjacent ones in a contiguous island. And by doing that, I'll be able to count the number of contiguous islands. And the last thing I want to do is I need to mark, like I said when I was talking about earlier, I need to mark these as seen, as I already visited them. This is a trick to this problem that I don't know if anybody would notice from intuition. But a trick to this problem is you can simply sync what they call sync the islands. You can simply, when you've seen an island or piece of land, you can set it to 0 to sync it because you've already seen it. And so then when I get to the next one, when I look back for this one, it'll already be 0 and I'll just ignore it. So you actually can sync the islands that you've already seen until you get to the point of finishing out that contiguous island. And then by the time you're done, it'll just be all zeros. And then as you keep searching, you won't run into it again. You'll just ignore it. Like you won't try to process it again. In other types of problems where you can't just sync the islands like that, you would actually need to keep like a data structure of your visited cells. But in this case, we don't have to do that. We can just change these to 0. I just know that because I've done this problem before and it's a common problem. It's a famous problem. But yeah, that's not something I think I would have ever came up with intuition wise. But that's just something you would know from doing these problems a lot. So anyway, I'm going to jump to the code, man. I appreciate y'all sticking with me, man. I know people don't like the talking and all that stuff. But man, you got to explain. You got to be able to explain yourself in these interviews. That's the whole point. The whole point is not just to do just to code. I'm not saying it's the whole point. I'm sorry. That's crazy. But you got to code and get the right answer. Yeah. But that's half the battle at least. Like you can't just get on there and regurgitate the answer and not be able to properly communicate. Because working a software engineering job, communication you're doing a lot more communication than you are coding. Like you're doing a lot more reading code and working with your team and doing pull requests and explaining what the pull request is, and explaining what the code is doing. Working through requirements, understanding requirements, reading requirements, asking about requirements. You got to do a lot of technical communication. It ain't all just putting your head down and just coding. So I appreciate somebody said the explanation is good. I appreciate y'all, the people that actually appreciate it. But anyway, I'm going to jump to the code now. So we already done. So I think at that point I would ask the interviewer, hey, do you think my solution makes sense? They would probably say yes. I would hope that. I think that's a good idea. You should go ahead. That's the hint they kind of give you. Like, I think that's a good idea. You should go ahead and start to code that. You want to ask them, like, do you think I should start coding this solution? Because sometimes if you're way off base, they'll say, how are you going to do this? Or how are you going to handle that with that? Maybe you should think about this, or maybe you should think about that. They may use that as a chance to give you a hint. This is just kind of just how the interviews work. It's kind of a game a little bit. You kind of just got to play the game with them. And so, that's why I say explain yourself so y'all all on one accord. And even if you get the problem wrong, if you explain the solution right, they'll give you, most interviewers, or some interviewers at least, will give you some credit for that at least. Even if you get stuck on the coding later. But if you just jump to the code and they don't even know what the heck you're doing or what you're trying to do, then they can't even help you because they're like, I don't even know what you're trying to do, man. So anyway, I'm going to stop talking now. We're going to jump over to the code. We're going to slide right over here. This is leetcode.com, leetcode.com. If nobody knows what it is, or somebody doesn't know what it is. And they already scaffold the problem, the function out for it that you're going to use. I'm going to be using JavaScript. I know the internet tells you to just use Python all the time. That's not real world software development. Everybody's not using Python. A lot of people are using Python. Python's a great language, but I don't use Python day to day in my job. I use JavaScript day to day in my job. When I interview, I use JavaScript so I can show the interviewer that I know how to use JavaScript because the job is calling for JavaScript. I don't go in there using Python when the job's not calling for Python. You can do that, but it looks better to me to use what I'm going to use in the job and what I've been using, in the past years of my experience. JavaScript's a great language for doing coding interviews as well, in addition to Python. So if you can read Python, you can read JavaScript. So, for people that love Python, they're going to say, hey, use Python. Just try to be a little bit more language agnostic. Like if you're a real software engineer, you're not becoming allegiant to programming languages. That's not what you should be doing, in my opinion. As I've been in it for like 10 plus years, you don't just blindly become allegiant to programming languages. You become a little bit more agnostic. Now, I'm not saying you got to love every single language, but you should be able to read. If you can read Python code, you should be able to read JavaScript code. Those are very similar looking languages. Like you shouldn't just be completely out of your element when somebody's using JavaScript. So, and you should be able to solve problems. Like if your company comes to you, you're using Python all year, and your company comes to you and say, hey, we really need you to work on this JavaScript thing. You should be able to quickly switch over and learn a new language. Take your concepts you learned in Python and transfer them to learning another language. Like somebody said here, user 485 said programming languages are tools. Like what plumber just uses a plunger, right? Like build up your tool set and start to be a little bit more agnostic to the languages and tools that you use. Don't become like so blindly allegiant just because the internet loves Python. And I'm not saying that's the only reason Python is great. Python is amazing, used for machine learning, used for a lot of AI stuff. It's a great language, easy to read. It's an amazing language. Like I'm not downing Python. I'm not going to down JavaScript either. Like JavaScript still runs the web, so still a very popular language. So anyway, I'm gonna use JavaScript. I know I went on a tangent there. LeetCode scaffolds this out for you in the language you choose. I'm going to change this to const. If you know JavaScript, you know that const is the proper way to initialize. So you don't want your function to be hoisted to the global scope if you use var, and you want to use const so that this function can't be redeclared and you won't have inconsistencies in your language. Inconsistencies in your algorithm or in your application from redeclaring some kind of function that you didn't know you were redeclaring. It's just best practice to use const in that case or use let in other cases before you use var. So that's why I'm changing that. I don't know why LeetCode puts that there, but I know if I don't change that, somebody in the comments is definitely going to say something. So anyway, yeah, we're going to do JavaScript, number of islands. And yeah, we're gonna go ahead and get started. I know I talked a lot, probably talked people off the chat, but some people joined in too. Oops, I screwed up my stream. All right, yeah, my bad. I didn't mean to do that. Yeah, so we back. Yeah, start number of islands. So the first thing I said I was gonna do is actually I'm going to put the LeetCode prompt on the top of the screen. Hope y'all can see that at the top. Oh shoot, I gotta move the camera back a little bit I hate that my stream key got screwed up. I had to move the camera a little back a little bit on TikTok. And hopefully I can make this thing focus a little bit. All right, it's kind of trying to focus. All right, yeah. So anyway, why does this like keep trying to autofocus? Like focus, man. Focus, bro. All right, I think it's trying to focus now. All right, maybe when I start typing, if I start typing something, yeah, when I start typing, it tries to focus a little bit. It's like, yeah, it just keeps trying to autofocus. I don't know if y'all see that or not, but anyway, I'm gonna keep going. All right, so first thing I said I'm gonna do is I'm gonna just start looping through my grid. The grid is a multi-dimensional array, a 2-dimensional array to be exact, and this is why you need to know your data structures and algorithms. You just need to simply know how to loop through stuff like this, like grids. To loop through a grid, I need to first loop through the rows. So for grid length, while the grid length, like it said over here, the grid length is M. That's the rows. So M is the rows. So if I go back over here, the grid length, and then rows plus plus. I'm looping through the rows, and then I also need to loop through each column on each row. So I could actually copy this down, change it to COL for column. And for this, I actually need to put the row that I'm on, the length of that, and that's how far I'm actually gonna go columns. But it's always gonna be the same thing. It's like the row, this length of that row is always gonna be the same. But I can just put this in here, just just best practice, I guess, or it doesn't really matter, honestly. So basically what this does is give me the current row and give me the column. What the current row and column creates is access to a cell. So basically how I can access the current cell is I can index into the row and then index into the column, and this equals the cell value. So this would either give me, like for 0, 0, this would give me 1. For 0, 1, it would give me 1. For 1, 0, it would give me, or my bad, yeah, 1, 0, this would give me 1, and so on and so on. So that's basically how I'm getting to the current values into my, from my grid. And so the first thing I said I want to do is actually check when I find a 1, because I'm looking for land, right? I'm not looking for water, I'm looking for land. So once I actually find a 1, that means I found a piece of land that I need to start searching for more land and build out an island of land. When I do find the land, like I said, I want to do what's called a breadth first search. So I'm actually going to create a function that'll start doing the breadth first search. And I'm going to pass the row into it. I'm going to pass the column into it. And I think I need to pass the grid into it too. I'm just going to pass that in there for now and see what. I just know I need to pass all my data in here. And then if I don't need it, I'll just remove it later. But right now I'm just going to pass everything I know about. I know I got a grid. I know I got a row. I know I got a column. I'm just going to pass every single thing I know about into this function because I think I'm going to need it. I'm going to do a breadth first search. And then after this breadth first search is supposed to find all of the ones connected to this one, and basically whatever that whole island is. And so once I do that breadth first search and find that whole island, then I actually can increase a count of how many islands that I have. And I ain't even create that. So I can create that at the top and can say count equals 0. And so whenever I find the island 1, and then I find the whole, I spread it out to the whole island, I find all the whole island there, then I don't know why this ain't focusing. Oh yeah, maybe it's doing it now. Anyway, when I find the island, I can just add 1 to it. And at the end, I can actually return the count, because that's my actual answer that I need to return. How many islands? This is number of islands. Since this is already named number islands, I'm just gonna call this count. And then every time I get here, I'm gonna increment it. And what I'm also gonna do is, like I said, once I find a 1, I'm actually gonna just set it equal to 0 to sync it in a sense. This is basically saying I already processed this cell. Like I already saw it, it's already been visited. So I'm just gonna set it to 0 so that when I do the breadth first search, that I don't loop back to it and find it again and then try to reprocess it. Like I'm already done with it, so I don't want to process it again. So I'm gonna set it to 0, and then I'm going to just pass everything in the breadth first search, and I'm gonna start doing some stuff in there. And once I do that, then I'm gonna update the count. And so every time I find a 1, it's gonna be every time I find an island, because when I go in the breadth first search, I'm also gonna be setting the cells to 0 too as I complete the island that I find. I'm just going to set it all to 0, the whole island. This is JavaScript, if somebody asking what the language is. Yeah, so we're going to jump into the breadth first search, because I haven't done this thing. And I hope, people that are joining, the problem is at the top of the screen. It's called number of islands on LeetCode.com. I'm in the middle of the problem. So sorry if I'm missing comments. You gotta focus, man. It's a medium level problem. I gotta focus. So I'm trying to read comments while I can. But I'm gonna definitely answer some questions at the end. So like I said, I got this breadth first search function here. So I'm gonna like go ahead and implement that down here. This is JavaScript, so I know it doesn't look as clean as Python, but JavaScript's pretty. It's dynamically typed just like Python is. It's pretty. It's not too verbose. Like there's not a bunch of verbosity in it. It's pretty clean language as well, so I like it. This is what I use every day for work, so this is what I'm going to use for all my interviews and stuff. So anyway, breadth first search, that's what basically is getting called right here, and I'm going to implement it down here. So I'm doing a separate function because it's going to get called multiple times. I could just put it up inside of there, but it looks cleaner to me to just start it like this. And if I want to optimize later, then I can just move the function code up inside of here. But you know, you in an interview, you kind of want to just make sure you're staying on track mentally. You want to try to avoid anything that will confuse you, and then you can just take it step by step to optimize later, because you don't want to get stuck on stupid stuff in the interview. The problems are hard enough. You don't want to get stuck on syntactical stuff. You don't want to get stuck on getting confused visually. You want to minimize all that kind of confusion type stuff, because it's confusing enough as it is. So anyway, let's go ahead and try to jump into this breadth first search. So breadth first search, this is something that's not going to just come out of the blue to you. This is something you would have practiced as you're learning how to do data structures and algorithms. It's just not going to come out of the blue, unfortunately. You have to have practiced it. And I know just from experience with a breadth first search that I have to build a queue. And a queue is just an array. And the first thing I'm going to put in the queue, and I'm going to explain how it works at least, but I just need to start writing it first. But basically I'm going to build a queue, and I'm going to put the row and column into it. And I'm going to try something a little bit different than I've done in the past. I'm going to actually try to build a object for each one of these. So I'm going to have an object inside of the queue. I'm going to put this object. This is a cell. Each cell has a row, and each cell has a column property. And I'm just going to set that equal to what got passed in here. And so the queue is going to start off, it's an array, and it's going to start off with this cell that I passed in to start. And then to process the queue, a queue is just an array, and a queue is it first in, first out, or first in? Yeah, I think it's first in, first. No, it's first in, last out. No, it's first in, first out. I don't know. I'm getting confused. How do y'all? Is it first in, first out, or yeah, first in, first out? My bad. Getting mixed up with a queue and a stack. So anyway, I'm gonna do queue. And how long am I going to keep this while loop going? I think queue length is greater than 0. Yeah, as long as the queue still has something in it, I'm going to keep looping. So I won't stop until this queue is completely empty. So I'm going to keep pulling stuff out of this queue. And then when it's empty, yeah, it's first in, first out. I'm tripping. But yeah, once I start thinking about the code, I was like, oh yeah, it's easy. But yeah, I just kept getting confused. That's why y'all do these things, man. Because in the interview, and that's the thing people don't talk about a lot. When you get in an interview, you can study all you want, do all this stuff. When you get in an interview under pressure, that person sitting there watching you, I got all y'all watching me. But when that person gets there watching you, it's like that pressure can mount, man. I've seen some people get in there and they do so great in the start of the interview, and then once I ask them a coding challenge, when I have to do these, and when I have to interview people with them, I've seen people just turn red and they just forget everything and they just get stuck, and it's just the pressure. You got to get used to just the pressure. And so you just forget things under pressure, man. You just get weird, man. You start forgetting like stupid, simple stuff. And so what helps me by doing these lives is like I kind of got the pressure. It's not the same pressure, but it is a level of pressure with everybody watching and blah, blah, blah. Like I could forget. And, I just have to be comfortable with it. Like I have to be comfortable with just, making some mistakes. So yeah, for people, somebody asked what I'm coding on. I'm coding in JavaScript. This is KG.codes.com. I'm doing a problem at the top called number of islands. The problem description's at the top. It's a little small, but that's what's up there. So Hopefully you can read it, or you can look up number of problems on your own. But yeah, I mean number of islands on your own and figure it out. But anyway, the pressure of the interview, that's what I was talking about. So anyway, we're going to keep going. I know that this is first in, first out. I'm going to keep looping till this is empty while it's greater than 0. And the first thing I want to do is actually pull out the cell that's in the queue. And how I can do that in JavaScript is do q.shift. Since q is an array, shift will pull the first thing out of it. So that's how I know it's first out. So the first thing I got in there now is just this object with a row and a column in it. And it's going to pull it out here. And then remember just thinking about how I was doing this, or how my solution was in my head. Whenever I get a item, I get on something I want to breadth first search on, I need to search all of its neighbors next. So I need to look at the neighbors and look at the one. So let's say this is a bad example, but let's say I'm like here. I need to look at the one on the top. I need to look at the one on the right. I need to look at the one on the bottom, look at the one on the left, and see if there's either zeros or ones, and then process them as such. So this is what I'm actually going to do is when I get the cell here, I'm actually going to start a for loop, and I'm going to say, and this is going to seem like I'm just like I got this memorized, and I want to be clear here. It's not that I have it memorized because I've memorized this problem. I haven't done this problem in a couple years, but it's memorized because I memorized the algorithm for breadth first search. Like I understand the algorithm, so I start doing things before it seems like I'm doing stuff out of order, but it's because I already know this algorithm. And that's the thing I tell people to use, like Algo Expert. I really tell people to use Algo Monster. It's the site that helps you learn the fundamentals first of how to do these problems versus just memorizing 1,000 problems. You learn the data structures, you learn the algorithms, you learn how to recognize patterns in the problems. And it's only about 10 to 15 algorithms you got to learn. You learn those 10 to 15 most important ones based on return on investment, based on the ones that show up in the interviews most. That's what Algo Monster, and I'm not a sponsor for it or nothing, but that's what it specializes in, helping you learn those patterns. And so this is one of the patterns, and they grinded this pattern into my head so much that it's like I just know it. Not that I won't make a mistake on it, but I at least know what it does, and I know how to code it. And you need to know how to code the algorithms from scratch, even without a problem. Like you just need to know how to code those algorithms. Binary search, depth first search, breadth first search. Because what these problems do is they add sort of a little twist to the base pattern. They'll add a little twist to it, or the base algorithm, they'll add a little twist. You got to know how to at least code the base pattern so you can add that little twist that the problem's going to have. Like this problem has a twist of islands and zeros and ones. You might do another problem that has a different twist on it. And so you need to know the base algorithm. That's the thing. If you're going to memorize something, that's the thing you should memorize. So anyway, somebody said, are you at Fang? No, I'm not working at a Fang company. I work at like a mid-size tech company, not a startup or anything, but it's like, this company sells stuff to other major companies and stuff. But anyway, yeah, I have past interviews for Fang though, like past interviews for Microsoft, past interview for Amazon. So like, these big companies. I pass interviews for small companies, mid companies, big companies. I failed interviews for these companies too. I ain't passed every interview. I ain't saying that, but I at least got the experience to say that I went through these interview processes and I gotten offers from the biggest companies to the smallest companies. I have gotten a very amount of experience. I don't know everything, but I know enough to at least talk about my experience, I guess. But anyway, so I went on a long tangent. What I want to do is say neighbor cell. And is it in JavaScript or of for looping through an array? I think it's of. I always get confused by whether this is in or of. I think it's of. And I want to have a function here called get neighbor cells. And there I actually want to pass in the row column. And I guess I'll pass in the grid too. And I know it's going across the lines. I hate when they do that. Dang, is there any way I can make this not... If I drop it down a line, yeah, I guess I can drop it down like that so it looks a little better for y'all. And then move this back. All right. Now I'll just make I might just make this like this. I really don't like dropping this down to a line, but it looks a little clean. I'm just trying to keep this from like, so y'all can see what the heck's going on. So I'm gonna just drop this line down. Yeah, so basically I got a loop here, and this is gonna find all the neighboring cells around the cell that I'm currently looking at, the current cell. And so this actually shouldn't be row or column. It should be cell dot row, cell dot column. I think. Yeah, cell dot row, cell dot column. Yeah, because that's how I've created this like this. So cell dot row, cell dot column of this cell that I just pushed out. Find all the neighboring cells of it and loop through them and call that neighbor cell or neighbor. I'm just calling it neighbor cell. And then once I get the neighboring cells, I'm gonna have to build this function later. But once I get the neighboring cells, I can do something with those. And so with the neighbor cell, which is this, I can actually check. I think I want to check if that cell, like I said, when I find the neighboring cells, I need to check if it's a 0 or a 1. So I need to use the grid, and then I need to index into the grid with neighbor cell dot row, neighbor cell dot row, and then neighbor cell dot column if it equals, and this is doing that weird drop down thing too. Oh wait, this is, yeah, that's supposed to be right there. So yeah, neighbor cell, neighbor row, if it equals 1, then man, can I drop this? How can I fix this one? Yeah, this one might just look ugly, y'all. Trying to find a way to not make it drop. Well, yeah, you just got to just try to, if I rename this something smaller, and it's supposed to be C-O-L. But yeah, you just got to see that this is saying equal to 1 over here. I'm sorry. It just going to be hard to write that. But trying to think of any, I guess I could call neighbor cell something smaller. Maybe I'll call it adjacent cells, like ADJ. I like neighbor better though. It just reads better. So I'm gonna leave it neighbor cell. Y'all can see that this is dropping a line right here. So anyway, grid. So I find the value of this cell of the neighboring cell. If it's equal to 1, I actually want to do the same thing. I want to set it to 0. I want to sync that cell. I want to set it equal to, and it's gonna drop a line too. Dang. Maybe I just need to change the width, or no, that's not gonna do anything. I think I'm gonna, maybe if I zoom out a little bit. Is that too small? Let me know. Yeah, I hate how that's doing. Yeah, I guess I'm gonna rename this to adjacent cell. ADJ cell. So that means adjacent. Y'all just know that it means adjacent cell. ADJ. Adjacent cell. I'm just doing this so that this looks a little cleaner. Or as far as the line that keeps dropping lines. So yeah, adjacent cell. So if I find in the adjacent cell this value equals 1, then I'm going to set it to 0 because I've already seen it. I'm going to mark it as I've seen it by just setting it to 0 so I don't look at it again. And then I'm also going to add that into the queue because now I need to check, if it's equal to 1, I need to check its adjacent cells. So I'm going to add it to the queue. When I come back here, I can actually check that one next when I loop through here again. So I'm actually going to push this into the queue. And how I did that is that's the same as I did up here. I need to basically create an object for row and column and put in adjacent row, adjacent column. And this one's going to start dropping the line down. So but this one's cleaner. I can just do it like that. Something like that. push in. Yeah. Or I can save some lines by doing something like this or something like that. Yeah. So I'm pushing in the row and column. This is ugly, but I wouldn't normally do this, but I'm just trying to do this for the stream. But yeah, pushing in the row and the column, pushing this cell basically into the queue, so I would process it next as part of the next wave of breadth first search for this cell. And by the time this loops through and I get to the point where this queue is 0, that means I've processed this whole island. Like I've processed everything in that island and I've turned it to a 0 at that point. I've turned everything that every adjacent one, I've went to the next adjacent one around it and turned it to a 0. And after I've done all of that, then I'll come back up out of this breadth first search and update the count, because that means I've processed one full island of all the adjacent cells by doing a breadth first search from that first cell to all the adjacent ones along the pattern, the connected adjacent ones. And I set them to 0, so I forget it. So I'm done with them after I process them, so they won't get picked up again later. That's how I show that they've been visited. And then I push the next one in the queue and just start processing the next one, and so on and so on. And not really recursion. It's more just breadth first search. Yeah, it's just a queue. I think if I was doing like depth first search, then I would probably be using recursion. But yeah, here I'm just using a queue and just looping until this queue is empty. And once the queue is empty, that means I'm good to go. And since I'm doing, this is a mutation, JavaScript's a pass by reference language for objects. For value, it's passed by value for primitives. But for objects, JavaScript's passed by reference. So when I pass this grid in and I actually update it here, it actually gets reflected all the way at the top level. And kind of gets like hoisted back up through the chain. And I guess hoisted not the right word, but it basically passed by reference. So this value gets updated as well. So anyway, that's why you got to know your language. You got to know what data structures you're using, what their types are, whether it's primitive, whether it's an object, whatever the case it is. Oh shoot. It said I'm inactive on TikTok, so I gotta drag the puzzle piece. Like, what kind of crap is that? Anyway, that's why I need to get my stream key back working. I don't know what the heck's up with that. But anyway, yeah. So I think I over-explained that. And so the last thing I need to do is actually get adjacent cells function, which I didn't do, which is gonna give me an array to use in this loop. And so that's the final thing I'm gonna do. I'm gonna create this and why did I do that? It's supposed to be this. Yeah, like that. And this will just be row, and this will just be column, and still pass the grid in. What I need to do here is, like I said, adjacent cell of adjacent cell. I need to get every adjacent cell. And what adjacent cell is when I'm like here, for instance, I want to get the cell to the right, cell to the bottom, cell to the left, cell to the top. How you do that is whenever I'm at a row or a column, if I add 1 to the column and none to the rows, I'll get this one. To get this one, if I add 1 to the rows and none to the columns, I get this one. To get this one, I just subtract 1 from the rows and none from the columns, and I get this one. For this one, I subtract 1 from the columns and none from the rows, and I get this one. So by doing some subtraction or addition to the rows or columns, I can get each value around here. And so the algorithm I'm about to write is something that I've actually memorized on how to do this. And this is where memorization is okay with these sort of problems. Like, it's fine to memorize solutions and try to go to an interview, but the interviewers are hip to that. Like, there's 3,000 problems on LeetCode. They can ask you any of those 3,000 problems. So if you memorize, but they're usually only going to ask problems within about 10 to 15 that lend themselves to 10 or 15 patterns or data structures or algorithms. And so if you memorize the algorithms instead of the 3,000 problems, it's a lot easier, because then you can adapt those algorithms, like 10, 15 algorithms, to the 3,000 problems. Now, it's not going to be perfect. You're not going to get everything. There's some problems you just have to memorize. There's some problems out there that they're just weird on LeetCode, and you just have to memorize them. But there's other problems but to handle the most problems, you want to understand the foundational things, because what they'll do is they might not give you numbers of islands exactly. They may add some kind of twist to it that makes it look unfamiliar. And if you try to just memorize the number of islands, you might not get it. But if you memorized how to do a breadth first search and how to find adjacent cells, then you're better off. You better off for it. So how I usually do that is what I do is I create a array called delta row, and the delta just means that's which direction am I going. Am I going up, right, left, down, whatever. And then I create one called delta column, and what I'm gonna put in here is all the different directions I can go by adding and subtracting from the columns. So here I'm gonna put -1 and 0 for the first one. So that's if I go up. So I basically subtract the row, but I don't touch the column. I keep the column at 0. Subtracting the row makes me go to the cell above me. Here I'm gonna put 0, so I'm not gonna change the row, but here I'm actually gonna change the column to 1. I'm gonna go 1 over, which is gonna send me to that's gonna go to the right, the column to the cell to the right of me. For this one, I'm going to put 1. I basically got to just put all the combinations. For this one, I'm going to put 1. And these are not all the combinations. It's not a full circle. This is just left, right, down, up. So it's actually just 4 directions and not the diagonal directions. Because the diagonal directions will be like 1, 1, -1, -1. I'm not doing those. I'm just doing a combination between 0, -1, 0, and 1. And so 1, 0, that would send me, like I said, that would send me 1 row down. So that's down. And then the last one would be, don't change the row, but change the column to -1, which that would send me to the left. That'd be the item to the left me. So by looking at these, this one, this one, this one, this one, this one, this one, you get all the 4 directions. And so if I loop through this and take the row and column in each of these at each interval, then I get all the different directions I need. And so what I'm also going to build is a adjacent cells array. And I'm going to put all my adjacent cells in it. And I'm going to return that at the end. Adjacent cells. But then what I'm going to do here is, like I said, I'm going to loop through I equals 0. I is less than 4 because I got 4 things in this array. And so starting at 0 base index, that will get me to 3. So it's going to be I less than 4. Or you can say like less than or equal to 3 if you want to be more clear. I plus plus. And so then here I'm actually going to, let me see. Yeah, so here I need to actually, this is going to be my new row value. And I'm going to just take the current row value and just add the delta row value at I. And I'm going to make a new column and add the delta column value at I. And so what this will do, this will do is at I. So when I is 0, I'm going to start here and I'm going to start here. And I'm going to add that. That's going to subtract 1 from the row and add 0 to the column, which will give me, by subtracting 1 from the row, that'll actually give me the cell above where I'm currently at. But the thing is, the problem you have to account for is that what if I'm here and I don't have nothing above me, or I don't have nothing to the left of me? I need to account for that. I actually need to check the bounds of the grid and don't include anything that isn't within the bounds of the grid. So I gotta be careful about that. So what I actually need to do is actually do like an if statement to check. I need to check if 0 is less than or equal to new row. Like it can't be less than 0. And then, and yeah, 0, yeah, and new row is less than the size of the length of the grid, because it can't be. It's actually got to be the length of the grid, since it's zero based index and the length of the grid. It can't be the length of the grid or more, because then that means I'm outside of the grid. On the other side, it can't be less than 0, because then that means I'll be outside of the grid. So I just can't be outside of the grid. And so I can't even see my keyboard, but I also need to do the same thing for the columns, or something similar for the columns. New column, and new column is less than. And here I actually need to take, I think, the new row and then dot length. I hope that's right. But I mean, all the rows are the same, so I actually can just put like 0 here, actually. Because all the row links are the same. So, and then yeah, that will give me that. I'm gonna drop this down so you can see a little bit what's going on. Yeah, so I'm within the bounds. Yep, these are within bounds. So if I'm within bounds, I actually want to add that cell to adjacent cells. And how I do that is the same way that I did it, that I always did it, like with this little array thing, which I should have pushed this down like this. It would have been more clear what was happening. Oh no, it doesn't. It still screws it up. Well, I'll just do it like this then. Yeah. But yeah, basically take this, copy down here and do something similar. So for the row, I'm gonna actually put in new row. And for the column, I'm gonna put in new column. Yep, because that's what I want to put in here. So I'm just basically making sure I'm not outside of the bounds, and put it all in here. So usually I would get I would get all the adjacent cells as long as I'm not on the edge. If I'm on the edge, then this if statement would kind of keep me out of the edge of the bounds. And so this will return adjacent cells. Return adjacent cells will give me all the adjacent cells, which I'm looping through here. And then I would start processing those adjacent cells inside of here. And so, yeah, this is a medium problem on LeetCode for a reason. I mean, I wrote 3 different functions. Now, I could have wrote all of this in one big function, but to me, it makes it a lot more easier to digest when you separate them out. And then at the end, if you have time, in your interview, which interviews are like a time crunch, you can go back and add everything together. But this helps me keep my mind together about what I'm doing by making these separate functions. And so you don't have to do it like that, but this is the way I do it. And it actually it probably runs faster if I don't do it like that, but these are the conversations where you trade off for readability. You're trading off performance, a little tiny bit of performance for readability. Sometimes not a tiny bit of performance, just depends on what you're doing. So yeah. So anyway, this looks good. Like, I think now that I got that, I do my breadth first search. I add the count. I'm returning the count. When I get to this point in the interview, I would be done with the coding part. And some interviews I've been in, like Amazon, Airbnb, sometimes they don't let you run the code all the time. Like some of the interviews for Amazon, for instance, they didn't let me run the code all the time. Like I had to. Sometimes they had a code runner like LeetCode has. Sometimes they didn't. Sometimes they made me prove to them my solution worked manually by, writing down the variables, keeping track of everything in my head and writing it down and tracing through the code line by line to prove to them that it works. Sometimes they had me coding in a notepad. I wasn't even coding in any kind of IDE or anything. I had no syntax help, nothing. So be prepared for that in some of your interviews. If you can ask the recruiter, you can look on blind.com, you can look on glassdoor.com to find problems to see what kind of interviews you might be heading into. Most interviews I've been into, though, they actually do let you run the code. Like they have some sort of syntax helper and they let you run the code in some sort of IDE. In this case, if you've ever watched me do these lives before, sometimes I will actually do the code manually. And I'm going to show you how I do that, but I'm not going to, for the sake of time, I'm not going to do it tonight. But what I would normally do is I would set up all my variables, which, see, like even in this case, the grid would be freaking huge. And maybe I could do this problem with like a tiny grid. Yeah, maybe I could do it with like a 2x2 grid and manually. Oh man, it's just so much code to walk through. I really don't feel like doing it. Yeah, I'm not gonna do it, but I would like set up the grid like this or whatever. Like, I mean, I could set up like a 2-dimensional grid, but I would basically set up like all the variables up here. If I was like, back in the day, they used to make you go into the office for these interviews and do whiteboarding, where you actually write the problem on the whiteboard. You don't even run the code. You're not even on a computer. Like, you're just doing it on a whiteboard and solving it that way and writing the code down, like pseudo code, what they call it. But ever since the pandemic and they start doing more virtual interviews, you actually are coding now. But yeah, whiteboarding was a beast, man. I mean, you didn't have no syntax, you didn't have no computer help, you didn't have no muscle memory from the computer. Like, you literally had to get on a whiteboard. And like when you practice for interviews, you actually had to practice on a whiteboard to get used to whiteboarding. That's not too prevalent anymore. I heard some companies want to go back to it because people are cheating with AI too much. But I hope they don't go back to that, man. So anyway, but yeah, I would like write down I would keep track of all these variables, and then I would go line by line. Like when I got to this line, I would set this to 0. And then when I got to this line, I would create a variable called row, and that would start at 0. And then I got to the next line, like this one, I would create. So I would keep track of all these variables, and then as they change, I would update them up here. And then I would basically, I would have count, of course. Oh yeah, I already got count. And so as my program runs, I would update the count until I got to the end and just make sure that I actually get the right count by hand, basically solve the problem, see if my algorithm works by hand by running a solution through it and debugging line by line myself without actually running the code. Now, you might have to do that in an interview. Like, they might literally make you do that. It just depends on what interview you're in. Now, I'm not going to do it tonight. I usually only do it with problems on here that have smaller like data sets. Like, I'm not about to go through these like 5x4. Like, I'm not about to go through all these and run freaking 50 lines of code on each one. Like, I'm not about to do that. Yeah, I'm just want to explain to you how an interview might work. And so what I am going to do, though, what you should always do is at least verify line by line that your code, that you don't have any syntax bugs in your code. Your code does what you think it does, like at least logically, from the sense of, reading through it. And sometimes you should kind of logically try to run code, not run code through it, but just make sure it's logically doing what it's doing. You don't have to run an input and output on it, but you at least need to make sure that what you thought you wrote is what you actually wrote. Because sometimes I might have wrote column where I should have wrote row or whatever. And so I'm going to do that real quick. So count. Yeah, I got the grid here. Count is set to equal to 0. I'm returning it here, which I expect to do. I'm doing a nested loop. I'm looping through my rows where grid. I'm stopping at grid length, less than grid length, which is proper. Plus. Starting my columns here. I can actually just make this 0. Like, it doesn't, because all the columns is the same length. So at the column, whatever the 0 column length, then plus. Yep, less than. So that's right. If I find one for row and column that equals 1, then I'm going to go in here and change it to 0. And I want to start a breadth first search by passing in that row and that column I'm currently on in the grid. And then I want a plus here to add to the count. And then I want to return the count after I got through the whole grid. And then in my breadth first search, I do got a row, grid, and column like I expect. I create a queue with an object of row and column. I put that in there first. Start a queue that doesn't stop until, it has to be greater than 0. It can't be nothing in it. Then because this queue shift will fail. So I get a cell. Then I find all the adjacent cells with get adjacent cell. From that cell's row and that cell's column, and then I pass the grid in too. And then I say for my adjacent cell, row, and column in that grid, if I have a 1, then I set that same cell to 0. Yeah, regular equals versus a double equals for equality. And then I push that into as a new object, cell object, row with the adjacent row and column with the adjacent cells column. I push that into the queue, go up to the top of my loop, start over again. For that cell that I found with a 1, I pop it out, or not pop, sorry, shift it out, take the first thing off the queue. That's what I can explain. What shift is doing is taking the first thing off the queue. So a queue is first in, first out. So as I put stuff in the queue, when I come back up here to process, I put all these in the queue. Like every direction I find adjacent cell, if it, like let's say I find 4 with the 1, then I'm putting all those in the queue. And then when I take off the queue, I'm actually like dequeuing it, what it's called. I'm taking the first thing out of the queue and processing it in order that I put it in. And so that's basically what shift does. This is kind of bad actually in JavaScript. Shift in JavaScript actually is, I'm going to talk about time complexity later. It's a big old N time complexity, which ain't good because I'm already doing a nested loop here. And then so then here I'm actually, every time I dequeue, I'm actually like however much stuff I got in the queue. Well, yeah, I mean, it's kind of bad because but I only can have 4 things in the queue though, possibly, because I only got 4 directions. So it's actually not that bad to use shift here because the queue, it's just every time I dequeue, I'm actually doing 4 operations, but that's constant. It don't matter how big my grid gets, this is always will be 4. So it's not performant. I could do something that's a little bit more performant there, but it's not completely wasteful. Like it's not terrible. But I'm gonna keep it though. That may be going over people's heads what I'm talking about there, but that's like an optimization that an interviewer could ask for. Leak code might ask for it. My solution might fail because of this. I don't know. We'll see. So anyway, but yeah, I get here, push this in the queue. Then I just loop out of all this stuff. Once I get done with this, I've changed all of these to zeros. Theoretically, I would come out of this and just update the count. My adjacent cells, I need to make sure that's right. Yeah, I'm passing in set rows, column, grid, passing in row, column, grid. Delta is correct. Yeah, this is up. This is right. This is down. This is left. Yep. So those directions are right. Adjacent cells. Since it's an object, I can keep it as a constant, push things into it. Yep. While I is less than or equal to 3, 0 base index, give me 4 loops. And then I just add the column, delta row, delta column at I, make a new row. Check that it's greater than or equal to 0 for both the column and the row. Check that the new row is less than the grid length, so I'm not out of bounds. Also check that the new column is not out of bounds for the length of the columns in general for 0, since all the columns are the same. And then I just push into adjacent cells. I create the same type of object, this row column object. And then I return adjacent cells that I populated. So that would go back here and everything is good. So yeah, the code looks good to me. That's what I would do there. Yeah, somebody sneeze or something like that. He said, would a stack be faster? I think a stack probably would be faster than dequeuing using a queue, because I think in JavaScript when I use this shift, is literally has to create it has to update this queue to a new array. It has to move every single item in the array up. When it takes the first one out, it has to look at every single item in the array and move its position up by 1, which is actually not, it's like big old N, which is not expensive, but once you're doing like a lot of queues, it starts to build up. Versus if you, well, I don't know, but using a stack will be about the same thing. Once you pull something out the stack, you're going to have to update the array. And by updating the array, you have to go through every single item in the array to update it when you pull something out the stack. So the stack is pretty much about the same. Yeah. Well, maybe if you're pulling off the back of the stack, maybe you don't have to update every item though. So yeah, stack is a little different because you might decide to pull off the top. So yeah, you might be right there, but Yeah, it'd probably be less expensive. But what I could do with this queue is I could use like a I can't remember what they call it. I don't know if they call it like a round robin queue or something like that, where I actually keep a head, like a pointer at the start of the queue, and instead of using shift and dequeuing, I just move the pointer in the queue and I keep the queue. I never change the queue. I always keep the queue the same size. I just move the pointer in the queue. So I could change that, but I'm gonna actually make that be an optimization I do later if I do decide to do it. So all right. Anyway, adjacent cells. Yeah. Okay. Yeah. So I'm done. I kind of got mixed up there. I was like thinking about something, but yeah. So I think I'm done here. Yeah. So what I would do now is actually run the code through LeetCode.com. They let you run the code against a couple different test cases. So yeah, you see, man, see where I'm at with it. I looked at my code, man, so it should be pretty good because I did review it pretty close. Yeah, so I got test case 1 and test case 2 right. That was basically what it did. What LeetCode lets you do first is run example 1 and example 2 through your algorithm with their code runner. And basically I got accepted for both of those. So that's great. I can add more test cases. I could probably add something like for test case 3, 1, 2, and 3. I could add for 3, I could say, let me do like a 2-dimensional array like this. 2-dimensional array with, I want this one to be a 0 and then this one to be a 0. So this should give me 2 islands actually. So let me try to run it with that. Oh wait, did I put an answer in there? I think I messed up the test case. Yeah, I messed that up. I don't have to put an answer in there. I guess LeetCode knows how to find out the answer when I add the test case. I screwed up my test case. I didn't screw up my code. Yeah. So yeah, I get 2. So yeah, like I thought, you get 2 with that. So I just added my own test case just to. And so this is what you might do in the interview. You might add more test cases. The interviewer might say, especially if they make you run it manually, you may add your own test case and get the problem right, but they may give you like a test case that's kind of weird, and you'll be like, oh shoot, you know, I need it. Like they'll be like, how does it work with this test case? And you'll be like, oh shoot, it doesn't handle that test case properly, and you might have to run some more code to figure that out. And I also want to try like a 1x1 grid. And would it just be 1 or just 1? Yeah, it'd be like this, I think. I think it'd be like that. I want to try that and see if my algorithm still works. Yeah, so it still works for that when you get 1. Yeah, so all these test cases, it works good. And so what LeetCode also lets you do is, oh, I'm actually not going to run it. So I can't run it with LeetCode. LeetCode can run it against more test cases. What I actually want to do now is talk about the time and space complexity. So time and space complexity are a way to denote how well your algorithm scales as it relates to the size of the input as far as time and space complexity goes. So time is related to the runtime of your algorithm, how many operations it does, how much CPU that it needs to use to complete, you know, how much impact it has on the CPU, for instance. And then space complexity is how much impact it has on actual like RAM, like the runtime memory that you're using to run the application. Like, and that's your data structures and variables and how much like actual space is being used as it relates to the size of the input. So it's not direct measure of what you're using. It's more of a abstract way to represent how your algorithm scales in relation to time complexity and space complexity as the size of the input changes. And so the size of the input here is the grid size. The grid size is, in our constraints, is denoted by M for the rows and N for the length. And we know that the length or height can't be more than 300. So we already got a strong constraint right there. So as it relates to our size of our input, for time complexity, you want to look at what in your algorithm is actually scaling based on the size of your input. Once you define the size of your input, I've defined it as the grid length, the number of rows, and the column length, the number of columns in my box, in my grid. What am I doing in my algorithm as far as number of operations? How long this algorithm has to run in relation to the size of my input? That's what you want to think about with time complexity. Once you learn about time complexity, you got to study on your own. I'm not going to explain everything about it, but I know here in this algorithm, this is a key thing. I'm looping the size of my length of my grid and the length of my columns, the length of my rows and my columns. This is directly correlated. However many times this runs in here is directly correlated to M times N, the number of columns times the number of rows, the number of rows times the number of columns. So as this scales, as this scales to 300 max, that's how many I'm going to run. It's 300 times 300 at max. So this code, the amount of times this runs is scaling directly in relation to the size of my input. And when that grows, then this runs. This doesn't matter because no matter how big this is, this will always run one time. This will always run one time. Even this in here will always run one time inside of the loop. But as far as each of these individual operations will always run one time. But this whole thing will run as many times, M times N, as many columns and rows as I have. And so then you have to kind of look at down here, what is being added every time I do this breadth first search. Like, is there anything in here that's actually running exponentially? And so here what's happening is I'm actually starting to process these individual cells inside of here and set them equal to 0. And so the only cells I'm really processing is ones that have a 1. So at most, I'm going to process as many, I'm just going to process as many cells, and I'm never going to look at them again because I'm going to set them to 0 that are equal to 1. So time complexity and space complexity are also based off a worst case scenario. My worst case scenario is if I have like a whole thing full of ones, like everything is land and nothing is water, then this code is actually going to run a lot. It's going to run as many rows and as many columns as I have, rows times column. But I'm actually already doing that here. If all of them are ones, then I'm actually already was doing that here. And if I get here and go inside of here, I'm just going to look at I actually would do it here. Yeah, so if everything was ones, I would come here, do the breadth first search, and I would find all the adjacent ones, and I would hit each cell at least one time, which that means if I had 300 columns, 300 rows, that would be 300 times 300, whatever that value is how much this actual code would need to run. It would need to process each one of those. And so when you start getting into the deeper part of this, what gets weighted in time complexity is the heaviest thing. And so when I'm looking at things like this, all these things are sort of nominal compared to the 300 times 300 that I would have to do to check every cell. Because these things are pretty nominal. Like this is fixed to 3. Like no matter what the size of my grid is, like whatever is not related to the size of your input, most of the time you can just ignore. It's nominal. It's not going to scale with the size of your input. Like this is always going to be these 4 things, always going to be these 4 things. I'm always just going to loop 4 times no matter what the size of the grid is. I'm always going to do these things. These don't really change no matter what size of the grid is. It really doesn't matter. Like the grid length is a constant operation. And when I say constant operation, that means it doesn't scale with the size of my input. It just does it one time, big O of 1. And so basically this is pretty nominal to me. It doesn't really scale with the size of my input. The thing that really does is here's where I'm checking all these. I'm going to keep increasing this queue as I find ones. And worst case, if everything's a 1, I'm going to have to put everything in this queue. And so space and time complexity is denoted by something called big O. And I'm not going to go too much longer in this because I know this is kind of boring for some. Hopefully it's helpful for some of y'all because you got to explain as an interview. If you get the problem right and you don't explain the time complexity or explain it wrong, like very wrong, you won't pass the interview. You have to explain the time complexity. That really is the point of doing the problem, because you want to come up with an optimal solution that is valid time and space complexity. And the only way to do that is to understand what the space complexity is and time complexity is. So I'm actually going to just write these up here. And so, like I said, like the thing that is heavily weighted here for time complexity, the amount of times of operations I need to do that is heavily weighted, that's related to the size of my input, the grid length and the column length, is this loop here. And then this queue here that I'm creating, that at worst case, if I had all ones, would just keep looping to the size of the grid length times the column length. And so, and the thing is here, because this could also be like multiplicative, where I'm doing this many operations inside of here, which would be bad. But the fact is that once I turn these to zeros here, I actually never really like, I actually do complete this loop. So yeah, I guess it is heavily weighted on this, but I only do this like as many times. I only do this one time if I have like a whole grid full of ones, or for each island I have. And I actually just don't even go into here if it's not a one. So I would like just kind of skip over those cells. So really this is the heaviest weighted part. But in some cases, like the breadth first search will actually take the heaviest weight. Like if I had a lot of ones. And so, yeah, but I still think all this reduces down to what's called big O of N times M times N, where M is the rows and N is the columns, or you can just say MN. And space complexity pretty much the same too. Space complexity measures not the number of operations, but it measures, in addition to your input, what new data structures are you creating that scale in relation to your input. And what's scaling in relation to my input is actually this Q, I believe. I think that's the only thing there. The grid doesn't count. You don't count your input. You just count any new data structures you create. And like I said earlier, this Q could actually scale. If everything was 1 at worst case, it could scale to the size of N times M. So it actually, my space complexity, that's how much runtime, like RAM, if I ran this algorithm and I had 300 cells, it was that this Q could actually grow to that size, and that would actually need to be stored as RAM in the computer. And if you have a bad algorithm that goes crazy when the scale goes, like I say, it was 1,000,000 times 1,000,000 rows and columns, then it could be a case where your RAM on your machine actually goes out or whatever. And so that's why optimizing these problems, knowing about time and space complexity, managing your CPU on your machine, managing your RAM on your machine is why you need to write good algorithms. And that's why FANG companies ask these problems, because they deal with massive scale. They're not dealing with these side projects that we do when we're just building a side project for 100 users, 200 users, 300 users, 1,000 users, 10,000 users. They are dealing with millions of users per second that need to run through these algorithms. If these algorithms aren't written in a way that is performant and makes good use of CPU, time complexity, RAM, space complexity, then their machines will need to either vertically scale or horizontally scale, and that costs them money. Or if they don't scale, they can't scale, they just crash, and then that causes outages. That's why you see these companies have outages. Sometimes these outages are due to bad algorithms that can't scale properly, or they have a bad time complexity or space complexity as far as their scale. They scale exponentially. So as you add more data, they actually perform worse as you add more data. That's not good. But this is actually, I think it's called linear. I think if it's M times N, I think it's linear. And that means however much I'm putting in there, my algorithm is scaling linearly, which is not bad. That's not bad. It's not the best, but it's not bad time and space complexity. Now, if it was scaling exponentially, like M times N squared or something like that. Like that means however much I add is actually like multiplying times itself, and it's becoming more and more as I grow in numbers. Like it's uniformly in getting worse. Like, or not uniform, it's like exponentially getting worse. We all know what that means. And so that's not good. That means as more users come in or more data comes in, I need to process, my algorithm actually can crash my machines. And so that's how these problems, the concept of these problems, translate to real jobs. Now, most developers don't do these day to day because most developers either aren't dealing with that type of scale. These algorithms have already been built at these companies. Like a lot of these low level problems have already been solved like years ago when the companies first started. Or, your role just doesn't lend itself to needing to do this. Like I don't have to do these every day. But there have been times in my companies where people or I myself have written bad algorithms that cost the company hundreds, thousands. Hopefully, I have never done nothing that cost the company millions of dollars. But yeah, hundreds, thousands of dollars because the algorithm's bad. Like it causes outages. It causes lose customers. Causes you to lose users when you have outages. Or it causes you to spend more money on scaling your machines if you're using cloud. So you might have to pay. You might have a higher AWS bill or higher Google Cloud Platform bill because your machines had to scale to handle the load because your algorithm was bad. It's not always the problem. The algorithm is not always the problem, but there are cases where a bad algorithm can cause that, because you can't think of it as this simple problem here where I'm just kind of doing this stupid number of islands problem. Like these could be real resources. These could be database hits that I'm doing. These could be API calls that use up tokens. These could be accessing some expensive resource on the machine itself. It could be accessing a database, which in itself is an expensive resource. And so you need to optimize your resources and your algorithms. Or this could just be a lot of data that's just getting stored in this queue, for instance. Like if this queue is becoming too large and I have to sit that in memory, in RAM, like runtime memory, random access memory, that can cause a machine to fail, or it can cause a machine to have to scale, or it might just fail because like it can't, once you're running the algorithm on a single machine, it can't horizontally scale. It has to be vertically scaled. So once it taps out that machine, you might not take down the whole system, but whatever that current instance is trying to do, it might just take down that machine, might crash that machine. It might have to spin back up, but you've lost that process or whatever, that current instance, that process. So anyway, I just went in that long tangent just to explain why this is important, because I know a lot of people say these leak code problems are stupid, they don't have anything to do with the job. I don't like them, and I think they're a terrible way to interview people. But to say that they don't have anything to do with the job as a software engineer is just false. Now, you may not use them in your job. I don't use them every day in my job. But it can become times when you write bad algorithms, and it could affect the bottom line at a company. That's all I'm saying. And a lot of people, like if you have a front-end role, you might write bad algorithms every day. But sometimes it doesn't matter. Like sometimes it doesn't, like modern browsers are so fast. A lot of times they can handle a lot of these bad algorithms, inefficient algorithms, and without it actually affecting the user. And so in that case, you might not care because the performance for a front-end user, performance may not be important to a business. But like when you're processing million database records or whatever the case is, it may slow down your algorithm, may crash the machines, it may be slow to process. Like I remember I did an inventory processing thing in the past where I had to process like 7 million records a day. And my algorithm was fine when I was processing like 1,000 in my local environment. But as soon as they turned it on in production and we had to process like 7,000 cars to be shown for dealerships a day, then my algorithm just fell over. It just sucked. So I had to actually look at the space and time complexity of my algorithm. Really, it was the time complexity, and I had to make my algorithm more efficient. And so I was like, dang, that's when it actually does. That was the first time it really was a big thing, because it went from taking 6 hours to process all the records to taking like 30 minutes and that's bottom line. Like that helps customers see vehicles faster every day and all that stuff. So yeah, so I know I'm rambling, but that is really important thing to talk about. And I know there's a lot of comments and stuff I'm just talking through. I'm going to answer some comments too before I get off. But anyway, you can run this against, I got the space complexity, time complexity. You can run this against LeetCode.com against all of its test cases. It has more test cases than just these, where is it? Than just these 2 or 4 that I put on here. And so you can submit it, and it also submit it against other people's submissions on LeetCode and see how you rack up or how you stack up against other people. And I might not pass this. It may take too long. No, I guess I passed it. I was hoping that maybe I had something else to do, but looks like I'm done. So it ran it against 49 other test cases, which ain't a lot. Some of these have like 1,000. I beat 20%, 26% of other LeetCode submissions. It says you gotta take that with a grain of salt. If you run this again, it'll probably say something different. 22% of memory. So like I said, it's runtime and memory, time complexity, space complexity. LeetCode lets you analyze the space and time complexity. So yes, M, like I said, it's M times M. N, god dang. M times N. Like struggling to say that. For the time complexity. And it's the same for the space complexity. So they got this little, I guess, AI, Gemini or something, analyze complexity thing. So they let you use that 1 time a day. I can only use it 1 time. So yeah. So it looks like I did okay. I didn't do the best. But this is what I was saying about I probably could beat more if I make some optimizations to this. I'm not going to do it tonight. If I probably change this from a queue to like a headed queue, like a queue with the pointer in it, where I don't actually use shift, I just move the pointer in the queue. I wonder how long that'll take to do. I really don't feel like doing it. Let me try it. Let me say if I make something called queue head 0. Where queue head is less than queue length. Something like that. And then I actually want to pull out of the queue head. I want to use queue head, and then I want to, after I use the queue head, I want to add to it to go to the next spot. Yeah. So yeah, I'm moving the queue. Every time I dequeue something, I just increment the head of the queue. I actually can just do that like down here to make more sense to people instead of doing it inside of here. But that's what that does in JavaScript. But I'm just going to do it. Now, everybody don't know JavaScript, so I'm going to do it like this. I'm just incrementing the queue head here. And so basically what this does, I don't have to mutate the queue. I always just keep the same stuff in the queue. I just keep moving the queue head over time as I do this loop. And so as I keep adding stuff to the queue, I'm just moving the queue head every time I dequeue something. And so I don't have to mutate the queue because that queue shift is actually mutating the queue. I have to keep moving all the items up in the queue to 0. And that's kind of expensive. So let me see if that works as far as just running it. Yeah, so that works there. So let me see if I submit it to LeetCode again, if I actually get a better result. If it runs faster. Yeah, so see, it got a little faster runtime. I didn't save anything on memory, so I still got like 20% memory, but it actually beat 40%. So like you see there, if I just keep optimizing this algorithm, it actually just starts to run faster, like 66 milliseconds versus the last time I ran it. Wait, can I see the last time I ran it? Yeah, so the last time I did this problem, or submitted this problem at least, was 2022. Yeah, it ran 70. So, I mean, it didn't get that much faster. It just got about 10 milliseconds, 13 milliseconds faster. But every little bit matters when you're talking about scale. When you're talking about millions, billions of users, every little bit matters. So, yep. So, that's a good solution. But I probably could optimize this more even. I was going to say that. By probably moving these from separate functions. Moving them in line, like up here, just moving all of this stuff, like moving this separate function to inside of here first, and then moving this whole thing into side of here, into side, inside of here, probably be nice. And I probably could make these like global variables versus Like, I wonder if I just put these outside of here and don't have to init them anymore, if that would also help. Oh, and make sure I get it right. See if that'll make it faster. It's like little tiny stuff you can do if you want to just squeeze like more performance out of it. Yeah. Oh no, so it got worse. I don't know. But sometimes leak code, it just depends. Like it just you never know. Like that it's not that measurement ain't perfect. But it could just actually be worse. I don't know, by moving it outside of there. I thought that would be better because I wouldn't keep trying to re-init these. But yeah. But I think also creating this thing here, creating this object, I probably would save time complexity and space complexity if I just don't create this adjacent cells. It only has 4 things in it, but like I don't need to create this object and return it inside of this loop. I could just do everything that I was doing inside of here instead without having to create some kind of object, return it, and then have it like being used here. So anyway, like this is where I'm at with it. I think I'm done now. I probably answered about 20 minutes worth of questions. I hope that makes sense to y'all. I hope that was helpful. I'm going to put this little thing on the screen basically saying that, hey, I solved it. I'm upgrading my screen. I'm updating my screen. God, dog, I can't even talk. I'm updating my stream every single time to get a little better every time. So hopefully this makes sense. Yeah, this is basically saying that I can complete this coding challenge, and y'all can ask questions if you have any questions. I know I probably missed a lot of the people at the bulk when I was doing the problem because a lot of people probably jump off after I finish. But if you have any questions, just ask them in the chat. If you're on Instagram, how is m times n linear? I think n times n is linear. Is n times n linear? I don't know. I think it's linear though because it's not. So when you look at time complexity, that's a good question actually. I'm glad you asked that. So you look at time complexity. Look at the time complexity chart. I'm trying to think what else would it really be though if it's not linear. Get this crap out of the way. So time complexity. Now my little junk is in the way. Move this junk out the way. So time complexity, where we're at linear is big O of n. Then you have n log n. It's definitely not n log n, and it's definitely not n squared. Or sorry, yeah, n squared. So it's still gotta be this. Even though it's n times n, it's still linear, just based on n times n. Because if it was n, well, I don't know. Maybe it is close. Maybe it is somewhere up in here. I don't know, man. Maybe it is exponent. I don't know. That's a good question, bro. I'm confused, man. That's a good question, dude. Let me ask Chat GPT. Is big O... Move over there. Y'all can see that. Is big O m times n linear or exponential? I think it's linear. And I'm just not good at explaining why. Yeah. Oh, it's polynomial. Okay. So I had it wrong anyway. It's not exponential. It's polynomial time complexity. Linear usually means big O of n, where runtime grows in direct proportion to the input size. M times n means the runtime grows with the product of 2 input sizes. That's still polynomial because it's just multiplication of 2 linear factors. Exponential would be like 2. Oh yeah, my bad. I'm saying exponential, but I meant to say quadratic. But yeah, exponential 2 would be 2 to the n. Yeah, it's polynomial. Okay. Not linear or exponential. So, all right. So I was just wrong altogether. So I'm glad you asked that question. So I would have got that wrong in the interview, honestly. But I'm also not, the only practice I've been doing for interviews lately is just doing these leak codes once a week. So I guess if I really was practicing, I probably would have got it. I hope, but yeah, there's a chance I could have got that wrong. But that's why I get on here, and that's why people ask questions and stuff like that. So I appreciate you saying that. Yeah, you said it would only be linear. Bravish would only be linear if m was a constant, right? And if m was a constant, I probably wouldn't. I would just reduce it down to n. I would just say big O of n. I wouldn't even put the constant in there. Probably, I would just reduce the constant off of it. So you're right. I told first time here I had to deal with gig of data for generating a huge yearly report that at first took 40 hours with week of optimization. I managed to get it down to 5 or 6 hours. See, that's what I'm talking about. And you may necessarily not have to do data sources and algorithms to reduce the time. You may have had to do that too, but it's something you had to do to lower the time. You had to think about the algorithm that was being, or what I'm saying is you might not have had to think about time and space complexity directly, but you thought about something to lower the time. And so it's the same concepts that they're trying to test for at these big tech companies. And so I'm glad you brought that up. JavaScript, wow, I really want to learn. Yeah, JavaScript's a great language. Like Python's great. I would say either learn Python or JavaScript for your first language. I think picking one of those is some of the best because they're very readable. They're dynamically typed instead of statically typed, so they're easier to sort of you don't have to like declare the types and worry about type stuff just yet. They can be object oriented. They're object oriented now. Like JavaScript has a bunch of object oriented stuff. Python does too. So you can kind of learn about that. You're not forced to use it object oriented, but it has it available in the language, which is good. Yeah. So let's see. Do you think the use? Oh yeah, I'm not answering that. I don't know why. I'm talking about code and stuff, man. Let's see. I'm getting blind, enable dark mode. My bad. I forgot to do that this time. I forgot to I meant to do that from the start, like just enable the dark mode. My fault. And then I should have took a picture of this. I took a picture of this earlier for the stream. I should have put that in dark mode. My fault. I'll do that in the next stream. I'm just trying to make one little tiny improvement at a time for the stream. So I'll probably do that next time. Let's see. I'm gonna do some more questions till probably about 10:30 my time. Somebody had something about the N-word. I'm not gonna answer that. What typical ratio of interview asking system design? What is the typical ratio of an interview asking system design questions to coding questions? That's a very good question. So if you're at one of these tech companies that does interview rounds, like they do like 3 to 4 or 5 interview rounds, typically they're only going to have one system design interview. They might have multiple coding rounds, or what they call them, like leak code, coding challenge style rounds. And they're typically going to have one behavioral style interview where they ask you more of typical interview questions in other industries. Like they'll ask you like, when is a time that you had this experience? And can you give me experience when you had to do this? That's a behavioral round, which you should answer with the STAR method, which that's a whole nother conversation. And then they're going to have one system design interview where you need to talk about, they're going to give you like a scenario with a system that needs to be built. And they're going to ask you to talk about how you would design that system, how you would scale it. What are the pros and cons of the things you've chosen, the architecture you've chosen, the things you've chosen to build your system. You're going to need to talk about how to horizontally scale it or vertically scale it. You're going to need to talk about the components. You may need to talk about caching. You may need to do some napkin calculations to see what scale you need to handle. You need to talk about the requirements, like how fast do users need to see certain data, because you may decide to cache certain data if they don't need to see it fast. I mean, I guess that's answering more than what you asked, but yeah, typically the ratio is like 1 out of 4 or 5 interviews you'll do system design. Yeah, so JavaScript, I'm using JavaScript. This is not C#, but I do love C#. This isn't C++, this is JavaScript. I already enabled dark mode, a C++ live streamer. I'm sorry, I'm not doing C++. Uh, Somebody asked, yeah, that's crazy. I'm not gonna answer that. I'm not even gonna read that one. I started coding last week in Java. Yeah, Java is a super verbose language, but it's a powerful language. A lot of enterprise companies still use it. It's not dead. Don't let the internet fool you. A lot of enterprises you can still find jobs for it. And Java's a statically typed language, object oriented. You'll learn things like dependency injection. You'll learn how to use libraries, built-in libraries, third-party libraries. Like you'll learn a lot with Java that especially using Java frameworks with it too, that you can't learn, or you can learn in other languages, but you'll learn that language very quickly. And it's a very valuable language to have as career wise. I used it in my career multiple times. So yeah, Java's great. Just run the code. Yeah, I'm sorry, man. It's people just waiting for me to run the code. But I'm trying to strike a balance of like, is it a build up to me running the code, or is it like just pain for me to just take a long time to run the code? But maybe what I should start doing is just simpler problems or something. And so then people, because I used to do easy level problems, which I can go through a lot faster. So maybe that's what I can start doing, so people are less patient. Anyway, are you employed? Yeah, I'm employed. I'm at a tech company. I work at a tech company that provides chat. So like if you go to like Verizon.com, or you go to what's another company? United Healthcare. You go to some of these big companies where you have to chat in with the customers. I work on the chat that company that provides chat for these other big companies. So we're like the main one. Like most of the time, for some of these big companies is where you're gonna see my company chat is at. And that's probably the most I'm gonna say about my company. I'm not gonna dig into the details of the company just try to keep that world separate. But yeah, I am a professional software engineer. I'm a principal engineer at a real tech company. It is a tech company. It's mid-size. Provides chat for other large companies, like I said, like Delta and Verizon and some of these huge companies that whenever you chat with them and you decide not to call and you decide to just chat through the computer, most of the time, more often than not, you'll be using the chat box that we work on, that we provide. So yeah, I dealt with this stuff for like a lot of years now. Let me see. Any more questions on TikTok? Using if statements might optimize. Yeah, that might optimize it too to get a little bit more out of it. Dev saying, I appreciate you commenting when you was on here. I code on my iPad and tweak some code in my iPad heats up. I can feel it. Dang, your iPad. Yeah, so that's crazy. Your iPad, like CPU spinning more because of some algorithms you running. That makes sense though. Depends on what you're running. Let me see if there's any more comments. Yeah, I appreciate it, man. Before everybody jumps off, just try to, I ask, follow me, follow each other, connect with each other. If you have questions that I couldn't get to during the coding challenge, please DM me, DM me. I'll follow you back. If we get connected and we have a conversation, of course. Yeah, follow each other. Follow my channel for more tech content. I post tech content multiple times a week. And I do these lives at least once a week. I'm trying to move up to 2, but I'm at least doing once a week. And I answer questions and I do a coding challenge, and I might start doing other types of lives too. And yeah, so I hope that people join again in the future. And somebody said, bro, you got to do AI and cloud. No one codes anymore. You are very good though. Very impressive. Yeah, I wouldn't say that's true, but I appreciate you, what you said, of course. But companies still ask people to do these interviews. Now it is starting to change because AI is starting to be more prevalent. And most of the time in my day job, I'm not doing as much coding. It's more using AI and reviewing code and tweaking code based off if the AI get it wrong or whatever, or just or it doesn't have the right context to do it right. I'm either this context engineering for the AI, or I'm reviewing its code, making sure it's right, or tweaking its code to make sure it's right. So I agree. I'm not doing much coding like this day to day, but there's still like I have people that are interviewing that I know directly interviewing with these companies. I've interviewed with these companies. They're still asking these questions today. A lot of them still are. Enough of them still are to make sense for me to get on live and do this. Once that's not the case anymore, I'll probably stop doing these types of things and start doing more like AI coding and stuff like that on live, which I have done before. So I'll probably do that anyway, but I'll probably still do a couple of these too. Until that becomes the past. And I hope it becomes the past sooner than later. So I agree with you in some sense, but in the sense that no one's coding anymore at all. Some people still don't, there's a lot of devs that still are resistant to AI. AI isn't perfect. As much as it seems like it on the internet, that AI is just going to take over everything and it's just perfect all the time. It's just not perfect. Like we still need to engineer the context for the AI so it has its best context in order to do the best job. And it still makes mistakes. It still hallucinates. It still has a hallucination rate. Even if it's only 5%, once the 5% starts compounding, it becomes a lot more prevalent within your application. And so even if it's 1%, like over time, the issues add up just like a normal dev. So we still need a human in the mix, at least for the foreseeable future that I see. We can get into that whole argument. Every time I get on, we get into the argument about the AI. Is the AI going to take over everything or not? I'm probably not going to get too deep into that tonight, but yeah, that's kind of my thinking on your question or your comment. Bro is comparing in one line and reassigning to another. What the hell? Bro is comparing in one line and reassigning in another. Oh. I'm not gonna lie. Watching you code, I can tell you can't code. Aox. I hope you still on here, man, because watching you comment, I can tell you don't code, basically, because it's literally is the solution for the problem. If you take the solution, copy the chat GPT, it's gonna tell you it's the solution for the problem. If I run it on LeetCode.com, it's the solution to the problem. LeetCode just said it's an optimal solution. It didn't time out, nothing like that. So based on your comment, I don't know what you're talking about. I guess you're just one of those people that just get on here and just like try to comment against everything the person's doing. I don't know. I'm not trying to hate on you or nothing like that. I don't know what you're talking about. I don't know what I did wrong. There's nothing wrong on here. So anyway. But I appreciate you commenting though, man. I'm not gonna try to turn it negative. But I don't. Yeah, you can tell I don't code. That's crazy, bro. I've been doing. Like, if you look at my channel, I've been doing these problems forever, man. And I've been working in the industry professionally forever. So yeah, I don't know what you mean by that. But anyway, yeah. So let's see. I'm starting as a SWE intern in a week. Oh, that's congratulations, man. Say, congratulations. That's what's up, man. I didn't even know people were still doing interning. I'm not gonna ask you to share where you're going, but I mean, I would be interested if you like DM me and tell me where you were going, because I kind of want to know what is still happening with the job market. And so for you to get an internship, that's pretty good considering how bad the job market is right now. So I appreciate your comments on that, and I appreciate, I'm happy for you, because a lot of people aren't getting like internships. Yeah, I do have a job. That's most of the people who's asking if I like work as an engineer. So I'm not just talking out my butt about these interviews. I give these interviews, and then when I'm looking for a job, I do these interviews. So this stuff I'm talking about, it's my personal experience. I don't know everything. I'm not perfect at these coding channels. I'm not a perfect engineer. But I do got more than 10 years of professional experience, and I have passed a lot of these interviews at all different level companies. So I at least know enough to at least talk about it and give my opinion. I don't know everything. I'm not calling myself an expert or nothing like that, but I know enough at least to talk about the industry and talk about these LeetCode challenges to some degree. So I appreciate everybody that's commenting and supporting, and even the ones that's not supporting or whatever they're doing. I appreciate y'all too, because I need all the feedback. So appreciate that. Let's see. It looks like oh shoot, I did not, whoever I invited to the live, I did not mean to invite you to the live. My fault. So do not try to join. Let's see. Oh, I see a lot of comments on YouTube. Let's see. Dang, I missed a bunch of comments. I was dumb enough to do DSA in Java, but I got the hang of it. Whoa, yeah. Now that's tough. Nah, I ain't gonna lie, that's tough, man. I got a little loud right there. That's tough, man. DSA in Java because it's so verbose. Java's a great language, but it's so verbose, man. You have to write so much boilerplate to do the simple things you can do in Python and JavaScript. So I applaud you actually for doing it in Java, because if you do your coding interviews in Java and you go for Java roles and do it in Java, that's actually a nice sign. It's a positive signal in the interview is what I would call it. And so I wouldn't say it's dumb, but you definitely went the challenging route, learning to do coding challenges in Java. But I can't hate on you because people get on here and they hate on me for using JavaScript in the coding challenge. Like, it's like everybody comes on here is like, use Python. It's like, that's not the real world, man. Like, I did my whole last interview round. All I did was JavaScript. These companies aren't forcing you to use Python. Some of them don't even want you to use Python in an interview. They want you to use what the job description says. And so, anyway, what's your tech stack? So, yeah, I mean, that's a good segue into it. Typically at work today, I'm doing mostly JavaScript. In my personal projects, I'm still doing mostly JavaScript. I actually do some PHP on my personal projects. At work, we also use some Java, and in the past in my career, I've used C# a lot. And so I say probably my strongest languages I have is like, HTML, CSS, and they're not languages, but just technologies, and JavaScript as the language, and then also C#, Java, PHP. I know people hate on PHP, but I still like PHP. And I'll say those probably like my core languages, but I can go and work on any other language. Like I'm pretty agnostic. So I've written code in Python before. I'll go and but I don't just normally practice in those languages. Those are not my go-tos, but I'm pretty agnostic. Like, I don't see languages as something you just become allegiant to. They're just tools to an end, or, ends to a means or whatever. And I just picked the best one for the time. So I just wrote a Python script like a couple weeks ago at my job, and so it's gonna be used. So, it just depends. Like, it's a lot of questions on YouTube, man. It's great. I don't think I've ever had this many people on YouTube before. New devs most of the time do not think what will happen to a function to hit with 10. Yeah. So like he said, new devs do not think about. They write a function or they write some sort of algorithm. They think about it with them just trying out the function and them inputting data, but they don't think about when it's like 1,000 times data input. So when you have 1,000,000 records, 1,000,000,000 records, does your algorithm scale uniformly, or does it exponentially or quadratically perform worse when the scale increases? And that's not a good thing. And so that's what these problems are meant to help you try to solve. What projects can impress the interviewers? Real projects that you actually productize. That's a great question. I would say go do some freelancing. Even if you got to do it literally for free, do some contracting. I call it contracting instead of freelancing. Go find some real people to build apps for, preferably real businesses, apps or websites or whatever it is. Really build it for them. Put it at a URL, productize it, and put it on your resume. Those are the best projects. I got my first job off something that I built a social media site for these people. It was a contract. I put it on my resume as contract work. It was a short-term contract for like a year. Put it on there. And when I got in the interview, they said, hey, is it live? Can we see it? And I showed it to them in the interview. That was the best situation I had. That actually helped me get the job because I actually didn't perform that well on the interview. I feel like, I don't know, they maybe think different, but I don't think I performed that well. But once I came with that app and I could talk about it and I actually could log into the database and show them stuff, like they were like, oh, snap. So they was like, okay, you like really know what you're doing. And so that's what I would say, best project to impress interview. They may not always look at your project. Sometimes they just skim over it. But sometimes before the interview, they might even say nothing to you. They might go and click on your links on your projects. And if they just see a tutorial project from YouTube, then it's not gonna hold much weight as if you literally built a mobile app that you put in the app store, like, and they go download it and they're like, dang, this man built the app, like, and it got like a lot of users, or it got like good reviews on here. Like, they're really gonna think of you a little bit different. And so, how many times are you gonna visit a single value in a collection? So if you have a nested single for loop, you're gonna visit each value, other values. So that's n times n, or n squared. Basically, how many times you're gonna visit a single value in a collection. And so if you have a nested for loop, you're gonna visit. Oh, I think you were probably talking about when I was trying to figure out the time complexity, if it was quadratic. Yeah. So yeah, if you visit a node, single node in a collection n times, then it's basically quadratic. I don't think that's what I'm doing here. Just because of the use of zeroing out some of the cells and then using this breadth first search to search the cells. I think at most I'm just visiting the cells just at one time. I'm just looking for the worst case I would have if all the cells were 1, and I would go through a breadth first search and have to visit every single cell. So yeah. But I mean, yeah, it's complicated. Coding is part of the job. So just basically how many times X is repeated. Yeah, I guess I'm going back to when we were talking about the time complexity. Oh, y'all were talking to each other. Okay, that's great. I'm sorry. Yeah, that's what I love, man. When people get in the comments, they have a conversation with each other. Like, it's so much value on these different platforms. That is great. Yeah, so AI is just a tool. You should use it wisely. Yeah, exactly. That's what I think. It's not the end all be all like everybody's saying. It's in these companies' best interest to oversell what AI can do. So I just keep that in mind. Like, OpenAI, Anthropic, Google, even Apple, they're starting to try to step in the game. It's in their best interest to oversell what AI can do in the next 1 to 2 years. So just keep that in mind, that they are selling a product, and it's good for them to say that it's going to take your job in the next year. I think just the bad market, the economy might take the job in the next year, but I don't think AI is going to take anybody's. It's not going to take all the jobs. It's not going to be a job extinction level event. Now, will it take some jobs? Yes. So don't let me misspeak, because devs are going to become 10 times more productive. I've already become more productive at work and in my side projects because of AI. And so with devs becoming more productive, you need less of them. And so, yes, some jobs are going to be taken over by AI, and not in the sense of the AI is going to be doing their jobs, but the devs that are left are going to be so much more productive that you're not going to need as many devs. And so it's going to take some jobs, but this whole job level extinction in 1 to 2 years, you already CEOs talking about all the programming jobs are going to be done by AI in the next 1 or 2 years. I don't believe that, because they said that in 2022 when ChatGPT came out in 2022, late 2022. And I had to listen to everybody on live through 2023 talk about in 1 year, all programming jobs are going to be gone. Then in 2024, I had to listen to it. And in 1 year, all the programming jobs are going to be gone. Or back in 2022, they said in 2 to 3 years, all the programming jobs are going to be gone. And we're here in 2025 and they not all gone. And so I'm not listening to these companies try to sell me that all programming jobs are going to be gone in a year. Because I've heard y'all say that every year. I've heard y'all on the internet, some of y'all on the internet say it. And I've heard these companies that are trying to sell AI say it. They're in their best interest to do that. And so, I do think it's going to change the industry. It's going to make jobs be lost. But this whole job level extinction event thing, I'm not saying that's going to happen in 1 to 2 years. It might eventually happen, but I think it's a lot farther away than they're saying. So anyway, I can go into the whole thing about LLMs and the limitations of LLMs, and if we're going to reach AGI anytime soon, and I can go into all that, but I'm not going to go into all that tonight. And I think we're probably starting to wind down anyway. So, do you think it's worth it to learn a bit of low level C for web dev? No, not for web dev, not at all. I would I wouldn't say it's valuable for web dev at all. C, no, that's way too low level of language for web dev. Like I don't think you need to know C at all. I would just know JavaScript for web dev and HTML and CSS and TypeScript maybe nowadays. And then just really get good with AI tools. You know, how to prompt AI, how to give it the proper context. You know, that's what I would say for web dev. I mean, anything, AI for everything. But yeah, as far as languages you need to know in order to help review AI written code and help prompt the AI, I would say JavaScript for sure for web dev. And maybe, I mean, if you're going to be a full stack web dev, like if you're going to do more like full stack, maybe you need to know a back end language or something. Is front end dev dead? People be telling to stop focus on it. That's completely nuts, man. Front end web dev is definitely not dead. That's the internet talk. There's a difference between people that's in the industry and people working in the internet. Front end web dev is definitely not dead, man. Like, yes, AI is able to write a lot of code, but it's able to write code on the back end too. So you could say back end, if you're gonna say front end web dev is dead because of AI, then you could say the same thing for back end. Like people think like back end's like more safe, like it's, you know, it's about the same. Like the AI, if anything, the AI would have a harder trouble with like visually, because you know when you try to generate AI images and AI UI, it still can kind of look kind of funny sometimes. So if anything, I would say it actually may be even harder for front end to get taken over by AI. So I definitely don't let this AI stuff scare you out of pursuing certain areas, man. I just think there's gonna be a lot of AI assisted roles. So you need to get really good at using AI, but you also need to get really good at the fundamentals as well. So that's what I would say. So Coco J Shay on Instagram. I want to learn more about this stuff. Hey, yeah, I appreciate you joining. Yeah. Yeah, just DM me if you got any questions. And I don't know which part you was talking about, but yeah, I appreciate you joining and commenting that. Especially on Instagram where it's like barely, it don't be a lot of folks on there, but I think with Instagram they just be like people be accidentally clicking on the live because it's like in the front, and I don't even think people really watch like lives like crazy on Instagram like that, or not mine at least. I get most of my viewers on TikTok or YouTube now, or sometimes X has a lot of people. So like I said, follow me on all these different channels. You can see my content. I post the similar type of content, and follow each other. DM me if you have questions that I couldn't get to. I think I'm gonna wind it down now. I see the numbers starting to wind down since I finished the coding challenge. So I might do like a whole Q&A next time and see how that goes. But I'm definitely gonna do more coding challenges. I think it's still valuable. I know it's still valuable. And I appreciate y'all. I appreciate everybody that stayed with me to the end. I appreciate everybody that joined along the way. Everybody that commented. Everybody that did something on there. I appreciate y'all. And yeah, appreciate it, Bravesh, for subbing or whatever on YouTube. I appreciate it, man. Reach out to me, man. Definitely. I love your comments and everything. You had some of the best comments there, so I appreciate it. But yeah, I think I'm gonna end it right there, and I appreciate y'all, and I'll see y'all in the next live.